Here we have some questions pertaining to linear functions, but the style of questions are relatable not only to linear functions, but all the other types of graphs we look at this level of mathematics. So hyperbolas, exponential functions, even circles as well. So let's go ahead and have a look at this first question and tackle one question at a time. So draw the function y equals 2x minus 3 for values in between -2 and 2 for x. All right, so as soon as you're asked to draw a function on a Cartesian plane, your immediate reaction should be to set up a table of ordered pairs. And so I'm going to do that below here. I'm going to set up my table of ordered pairs. I'll do it right here. X and Y. I'll use some straight lines here. And I'll start filling out my values for X because I know I need to find out where the coordinates are between -2 and +2. -2, -1, 0, 1, and 2. So what I need to do is substitute each of these values, -2, -1, 0, 1, and 2, one at a time into my expression here, substituting in for x to determine what the value of y is. And that'll start making some coordinates. We can start plotting. All right, so what I'll go ahead and do is I'll show one how we substitute, but then I'll do the rest, I suppose, out loud. So for the first one, when y is equal to -2, because that's our first value here, -2, I'll go ahead and substitute y equals 2 times 2 minus 3. All I did is I rewrote the function up the top, and I replaced or substituted x for 2. Sorry, -2. Let's go ahead and fix that up. -2. All right, so let's go ahead and start working on this. So 2 times -2 is, well, that's -4. So -4, take away 3. Our y coordinate here is going to be -7. So in here, it's going to be -7. All right, I'm going to do the same thing, but I'm going to do it out loud for the rest of the other numbers. All right, so when x is -1, it's going to be, well, 2 times -1 is just -2. Take away 3 is -5. All right, what happens when x is 0? It's just going to be 2 times 0, which is 0. Take 3, it's -3. Now, by now, you should start seeing a pattern. And the pattern is we're going up by 2's. So I predict this next one should be -1. Let's have a look. So when x is 1, 2 times 1 is 2. Take away 3, -1. The next one should be 1, I believe. So 2 times 2 is 4. Take away 3, well, that's just 1. All right, now I have a table of ordered pairs. I'm going to use this table of ordered pairs to plot some coordinates on my Cartesian plane. So when x is -2, y is -7. Let's go ahead and put a coordinate there. So when x is -2, y is -7, right there. So let's get my pen out. Right there. When x is -2, y is -7. All right, next one. When x is -1, y is -5. Right there. When x is 0, y is -3. When x is 1, y is -1. And when x is 2, y is 1. All right, I've now plotted my coordinates. What I'll do is I'll go ahead and connect them all. And because this is a linear function, I can use my straight line and connect all the dots all the way through. And so there we have a linear function that's been graphed. And my next question now is question 2. Find the intercepts of this function, y equals 2x minus 3. The intercepts, we're just talking about the x and the y intercepts. Where does the line cross the x-intercept, and where does the line cross the y-intercept? So how would you answer that question? Well, here's question 2 here. I'll put the answers below. Let's get out of our straight edge. So for question 2, the x x-intercept, let's go ahead and lower this a little bit. The x-intercept is equal to, let's go ahead and have a look at it, right there. Now, because I've got an accurate graph here, I can see that my x-intercept is at 1.5. 1.5. So I'll go ahead and write 1.5. Or you can write it as 3/2. All right, let's go ahead and write our y-intercept. Our y-intercept is equal to where the line crosses the y-axis, and that's right here. And luckily we had a coordinate for that, and that's obviously -3. So zooming back out, -3. All right, so let's go ahead and move on to question 3. Is this point 1, -1 on the line? Is 1, -1 on the line? Well, we know that for a fact. 1, -1 is on the line, so yes, point A is on the line. But can we do this algebraically? If we didn't have this coordinate here, say if we didn't include this value, if we just erased this value, could we determine this without having a table of ordered pairs? Well, we certainly could. We could figure this out by substituting these coordinates into our function. And the rule is this: if you substitute a coordinate into a function, if the left side is equal to the right side, then that coordinate is on the line. But if it's not, if you get two separate results or two different results, then that coordinate is not on the line. Let's go ahead and demonstrate this. So we already know the answer. We know that 1, -1 is a coordinate on the line, and I've actually already done it here. It's 1, -1. That's it there. But let's go ahead and determine this algebraically. So what I'll do is I'll write the equation again. So question 3. So y equals 2x minus 3. Let's go ahead and substitute x for 1 and y for -1. -1 equals 2 times 1, take 3. Now, if the left side becomes equal to the right side, then we know that these coordinates are on the line. Here we go. -1, let's do some solving on the right-hand side. So 2 times 1 is 2, and 2 take 3 is -1. So we just determined algebraically that the coordinates for point A, so therefore A, which has a coordinate of 1, -1, is on the line.